Okay, so a big welcome to another lecture series on electronics, and this time I'm going to talk about logic gates. So this is a follow-up on basic digital electronics. So I taught you in a previous chapter what digital electronics is, and now I'm going to teach you some devices that make use of digital electronics. So if you remember, digital electronics is either ones or zeros. Yeah, so they're either high or they are low. Okay, so today I'll be talking about logic gates. Now, logic gates are devices that take in these digital signals. So they take in these digital signals into something called a logic gate. And what it does is that it gives you out another digital signal. So it gives you ones or zeros. Okay, so this fella will actually help you make certain decisions automatically on its own. So you don't have to be there to always decide. So these logic gates will help you make decisions. Yeah. So there are many different types of logic gates. There are one input logic gates. That means if I put in one input, um, they will give me one output. Okay, so therefore you have one input, either a 0 or a 1, and it'll give you either a 0 or a 1. There are two input logic gates. So if I have two inputs going into a logic gate, I will have one output going out, always one output. Okay, so in this case, I have two inputs, either A or B. So there are many different scenarios that we can have, right? And this is the part where you have to remember this pattern. So you have to remember that this is always represented in a table, and this is called a truth table. So if there's two inputs, let's call these inputs A and B. This is the pattern you always have to follow. 0, 0, 1, 1 for the first input and 0, 1, 0, 1 for the second input. Now, can I have input B here and input A here? Sure, no problem, it's up to you. But you must always follow the first column is 0, 0, 1, 1, second column 0, 1, 0, 1, alternate. So always remember the first column, we always put the zeros first, followed by the ones, and the next column is the alternate 0, 1, 0, 1. There are also three input gates. So if I want 2, 3 inputs into a gate, this will help me decide what's going to happen here, and it will give me one output here. So the output in this case is X, the output in this case is X, the output in this case is X. So if you have three inputs, A, B, C, you have to draw the truth table in such a way that you now have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. And same thing, write all the zeros first. So 4 zeros followed by 4 ones. Next, you have to alternate the zeros and ones. But now, because we have a 4 zeros and 4 ones, it will be 2 zeros, 2 ones, 2 zeros, two ones. And finally, the third column, 0, 1, 0, 1, 0, 1. So there is clearly a pattern to this. You have to remember this pattern for your inputs. So input, there's nothing to think, there's nothing to understand. You just remember the pattern. Okay, for three input gates, giving you one output, this is the truth table. Remember the pattern. I will teach you how to derive the output. So far, all I'm talking about is the inputs. Inputs are always fixed. So far, all I've taught you is how to remember to write the inputs for a truth table. And this is very important. Always remember to write your inputs in this pattern. Okay, remember this. So go and remember this. What you can do is that you can cover these numbers, draw your own truth tables, and see whether you can remember how to draw one input, two input, three input truth tables with the inputs like this. You can leave the outputs blank. I'll teach you how to derive the outputs later on. Okay, so for now, I'm going to stop the recording now. go and read through this chapter in the textbook and remember how to draw the inputs for the truth table. Okay, see you in video 2 where I'll be talking about the gates themselves. See ya!